and I'm going to ask a volunteer to share with us. Okay, let me first stop sharing a bit. A volunteer to share with us what you understand by energy. Okay, we start with Mary Blessing. What do you think energy is? Okay, Mary Blessing.
Energy is the ability to do work.
Energy is the ability to do work. Very good. That is correct. Any other person with an idea? Okay, Sean.
I had the same idea as her.
Okay, the same idea. Good. Okay, any other? Benis. Okay, Benis. Okay. Okay, good. So energy, when we talk about energy, so today our concentration is going to be energy. So energy is that ability to do some kind of work. So we have different forms of energy, and one of the forms of energy we are going to look at is what we call chemical energy. When we talk about chemical energy, that is the kind of energy that we find in food, we find in fuel, we find in gas, we find in wood, we find in coal. So the energy of the fuel, the energy that is used for burning, for cooking food, we can say that is chemical energy. And now, but we have other types of energies, other forms of energy. Can we raise up our hands and then mention what are some of those forms of energy? You know, and you have heard about. Yes, I start with, yes, Isaac. I didn't get you well. I didn't get you well. Maybe you can type. You can type. Melissa.
Solar energy.
We have the solar energy. Good. Sean, karibuni. Sean, karibuni. Oh, Sean is not unmuting. Divine. Oh.
Light energy.
We have the light energy. Good. Austin.
Sound energy.
We have the sound energy. Good. Edina.
Thermal energy.
We have the thermal energy. Okay, then user.
Physical energy.
Physical energy. Good. Martha.
Electrical energy.
Electrical energy. Faith. Good.
Heat energy.
We have the heat energy. Joshua. Joshua. Sengendo.
Kinetic energy.
We have the kinetic energy. Jeremiah.
We have magnetic energy.
We have the magnetic energy. Good. Juan.
Atomic energy.
Atomic energy. Good. Heaven.
Right.
Yes. Heat energy. Okay, good. Nina.
Sound energy.
Sound energy. Thank you. Blessing and Tracy.
Magnetic energy.
Magnetic energy. Thank you. Okay. Okay. I think those are some of the different forms of energy that we have. And you can notice that from all those forms of energy that you have mentioned, they can be used to do something. When you talk about solar energy, where do we use solar energy? Or what is solar energy used for? And where do we find solar energy? Or how do we obtain solar energy? So you can, okay, we start with Faith. Yes, Faith? Okay. Okay. Okay, Natasha, where do we find solar energy?
Solar energy is bought from the sun.
Okay,
Like
good.
those light rays that come from the sun, they come from the sun with heat. So that those light rays combined with their heat, they make up solar energy.
Wow, wow, wow. Thank you. Thank you. Good. Cats. Cats. Okay, okay. It seems Blessings, you have something you want to add on?
Teacher, I'm answering the question of how we use solar energy. So
Okay.
solar energy is used to charge solar batteries that are used for lighting in houses.
Okay, okay, good, good. Okay, now we are going to start our writing, but as we are going to start, you write what is energy, and I want everyone to define energy the way you understand it. So, good enough, they have given us the definition of what energy, and then we look at the second form of energy. So the first one we are going to look at is going to be chemical energy. I know many of you at home cook, and I know some of you use charcoal to cook, others use wood to cook, others use gas to cook. Okay, so let us first now take note, make a small write-up on forms on energy and then the different forms. Make a small write-up. Yes, and please don't forget, at the end of the lesson, at 3:30, we are going to do an exercise. So when you finish, what you do, you just go to the chat and say, yes, we can continue after summarizing. When you finish summarizing, you tell us that you have finished. Yes. So chemical energy, like when I'm talking in terms of food, you can say that whenever you eat food, the energy, chemical energy in the food is converted by the body into what you call mechanical energy. And then lastly, it can be also converted into heat. So for you to gain the energy, it means that the food you have eaten has been converted. So when you convert the food, because of the different chemical reactions, you obtain the energy that you can use to do some kind of work. Okay. 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 Have we finished? You just say yes in the chat, and then we can move on in case you have finished to put up that point. Okay, I'm saying 2 yes. Okay, people are good to go. Are we all on the same page? Okay, good. So we are going to look at the second form of energy. Yes, like many of you mentioned, we have another form of energy we call electrical energy. So when you look at electrical energy, let me ask those who know. In Uganda, where is electrical energy produced from? Where do we find that electrical energy? And which industries deal with that energy? Okay, Natasha?
In Uganda, the electrical energy is formed at Jinja Dam on the
Okay,
River Nile, and
okay. Mm-hmm.
some of the industries that deal with the electrical energy we have umeme and yaka.
Okay, thank you so much. Sean?
So most of the energy is generated from dams, not only from Ginger, but there are also some other dams that are still in construction from other rivers.
Okay, do you have an example of any dam, you know? Yes, Sean?
So I think Karuma Dam.
Okay, in Karuma. Okay, good. So we have Karuma. There is, I think, I don't know whether it has already kicked off, but there was a proposal that it is going to be used for producing electricity. So how is this electrical energy found? I'm going to stop sharing a bit. Be patient. I want to show you something, how the electrical energy is produced.
Well, according to the contractor, Sino Hydro works on Karuma Hydropower Dam in advanced stages, and very soon 3 units adding 100 megawatts are set to be commissioned. We have reached
Okay. Now, when it comes to the electrical energy, in order for it to be produced, there are some things that must be able to take place. So
due to the torrential rains last year, there has been a drastic increase in Lake Victoria.
So when you look at the video, this is the Ginger Dam. So this is where we have our dam in Ginger, those who have gone to Ginger. And that water you are seeing, it is the one that is coming from the dam. So what does it do? Now, inside the dam, we have, like, we call them turbines. That water, since it comes at a very high speed, it keeps on rotating those turbines that later on lead to the production of electricity. So that water you are seeing that is flowing at a very high speed is coming from the dam. That's where now the electricity is being generated. So those people who usually visit Ginger, mainly in the morning hours, those who use the old bridge, you'll find that water flowing at a very high speed. And those who usually pass Ginger at night, even that water at the dam at times is closed. So they cross the bridge and you find that the water at the bridge is much. In fact, even it reaches the upper ends. So that is the one we have. Then another one that the government is going to produce is going to be in Kaluma, and I think they have already constructed. Those who have gone to Gulu ends, I think you must have crossed Kaluma. So also when you look, when you reach Kaluma, the falls are very, very fast. So you find that those ends, the water is very fast. Let me also show you. You can also reach Kaluma and you see what really takes place. So when you look at the screen, this is what we call Kaluma Bridge. So where these trailers are coming from, those trailers are coming from Gulu. So that is the Kaluma Bridge. Also, the water runs very fast. So for any area where the water runs very fast, it is an indicator that in that area, we can be able to produce electricity. Why? Because that water, when it is moving very fast, it means that it can be in position to turn the turbines around, and therefore we can be able to generate electricity. So those people who stay in Gulu, those ends, you can be able to see that there is going to be. So Karuma Bridge, I think it's going to be adding on about 3 units of electricity to the one that we have been producing. So that's what you call electrical energy. So that one, we use it at home, we use it in industries and the rest. Then another one, we have what you call a strain energy. Many of you have had a rubber band. When you buy some things at home, at times you get a band. So when you try to pull the rubber band apart, it usually makes some noise. It extends. It being elastic, it also goes on to expand a bit. So that kind of stretching of the rubber band, it means that there is some energy being stored inside the rubber band. So that kind of energy is what we call the elastic potential energy. So those are the two other forms of energy. We have said we have many, but here we are looking at just some. Okay. Okay, so we can make some right up. So let's make some right up. So you can be able to produce electrical energy at home. Those people who have that running water, you can be able to produce that kind of energy at home. It just requires water that runs very fast, and it is mainly produced by rivers. So hope you have been told in geography that for any water that keeps on moving, we are told that is a river, and the water that is a bit stationary, that is a lake. So being that rivers always move, their water moves around, so that one can be easy to generate and turn the turbines. So we are making a laptop, but here you after the lesson, you're going to go and expand on your own, make more research about chemical, make more research about other forms of energy. Because we are not going to exhaust all, we are going to look at a few, then the rest you can be able to find them out. Like people mentioned magnetic, mentioned a lot of types, but we are going to look at mainly a few, and then we dive into the two main forms of energy. Hope everyone is taking. When you finish, let us know. Okay, Sasha's finished, so we are waiting for the rest. Okay, done. So when you finish, you let us know such that we can move on. Done. Okay, done. I think some members are finished. We can move on. We can move on. So we are going to continue. So we have other forms of energy, like you mentioned. We have what we call the heat energy. So these are other forms of energy. But since I want you to make more research, I'm going to ask you to research more about other forms of energy, such that you can write detailed notes about them. So here, I'm going to jump this slide, but I want you to put in your book activity, read more about other forms of energy, like heat energy, light energy, sound, nuclear. So that is your task that you are going to work on. So that is the second task, or that is your task that you are going to work on. Hope that is fine. Hope that is fine. Yes. Now I'm going to, okay, hope that is very okay. So you're going to read about other forms of energy. Okay. So I'm going to move on. We shall read about them, and then feel free to share what you get. Okay. So we are going to look at now the main, what we call the main forms of energy. Now, the main forms of energy, we shall have basically there are two. The first one is what we call kinetic energy. And when they talk about kinetic energy, they are looking at that form of energy that bodies that are moving possess. Whenever a body is moving, whenever you move from one place to another, you are moving from, let me say, from this point, and you are going somewhere this side. The form of energy that is being used is what we call kinetic energy. So kinetic energy is that form of energy that is possessed by bodies under motion. So any form, like any moving thing, will possess what we call kinetic energy. So it is that energy that helps you to move from one place to another, from one point to another. That's what we call the kinetic energy. And being that it is kinetic energy, we need to know what are the S signs. So the formula for kinetic energy is given by half mv squared, whereby m stands for the mass of the body. So mass of the body is like your weight. In case you have 80 kilograms, in case you are 52 kilograms, in case you are 62 kilograms, that is what you call your weight. That is what you call the mass of the body. Then we have V. V stands for what we call the speed of the body. At how fast are you moving? You have seen people running very fast. So what is their speed? That kind of speed you are moving at is what you call speed. At times, depending on the circumstance, they can call it the velocity. Now, what is very important for you to take note of, that for all forms of energy, or for the energies that we shall be having, our units will be joules. And joules is the unit for energy. Whether you're dealing with kinetic energy, whether you're dealing with potential energy, whether you're dealing with kind of energy, always we shall have our units as joules, much as the other minor units we can have. Hope we are together. Are we together? Kindly unmute and talk to me. Are we together?
Yes.
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 Yes. Yes. Yes.
Yes.
Yes.
Yes.
Yes, sir. Yes.
Oh, okay. 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 So let's take notes, and then we look at some examples. We look at some examples. So when you finished, right, You just type in the chat that I have finished, such that we can move on. Okay, looking in the chat. Okay, let us take a hand. Patrin, is it Patrin? Annabelle?
Yes, so I have a question.
Oh, yes.
Why do we divide by a half?
Why do we divide by a half? Okay. Okay, I don't know if Sean wants to answer. Sean, do you want to answer? Okay. Sean, do you want to
Next, I
answer?
had another question.
Okay, also first ask. Ask. Okay, Sean, ask.
So I wanted to ask, since we multiplied by velocity, will kinetic energy change according to the different gravitational forces we have? Let's say you're on the moon, would the kinetic energy decrease or increase?
Okay, okay, thank you. Let me hope, yes, now can we get some answers from class first? Can we get some answers from class? Anyone with an idea? The first one was any idea? I want to know. Anyone with an idea? So, yes, kinetic energy change depending on two factors. One, kinetic energy depends on two things. One, it depends on the mass and it depends on the velocity. So remember, mass of the body does not change. Mass of the body does not change. So whether you have gone to the moon or where, your mass will remain the same. It is only your weight that can change. Then when it comes to velocity or the speed, your speed on Earth is okay. This one can be measured, but when you go to the moon, your speed changes a bit the way you move, because at the moon, like let me say, I can use two surfaces. When you are running in water and when you are running in land, your speed is totally different. When you are running in water, you run very slowly. So meaning that your kinetic energy will be very small. When you are running in air, you can run very fast on land or in the field, meaning that your kinetic energy is going to be big. So that's the same thing when it happens to the moon. Since the moon is made of sand and other materials, so your speed at which you run may be very slow. So you'll find that your energy is smaller compared to when you are on Earth. But when you can run at the same speed on Earth and on land, then on the moon and on land, then that can be very okay. But whenever you go up, whenever you go to the moon, there are some things that keep on changing. And at the moon, your speed at which you walk even is very slow. It is very slow. So when you find yourself that you can turn around the pitch at 5 meters per second, then up on the moon, you find yourself you can take a lot of time, because the surfaces at which you are moving on is not a friendly surface. Then someone asked, why do we have a half? Now, this half on the kinetic energy comes as a result of integrating what we call the equation for work. Now, you know very well, I'm not going to go deep into this mathematics, but we know that work is given by force times the displacement. Now, when we come to this, we know very well that force is given by, you can use MA, which is MA, then times D. Now, where do we get, where does but we know very well from here, we know that this is mass, but I know how do we get speed? I know very well that speed is given by distance is given by speed times time, meaning that speed is given by distance out of time. So here I'll have m, then my speed is given by distance out of time. So in case I want distance, I know distance is speed times time. So I can come here where it is this distance, I substitute the speed times time. So I'll have a, then that times the speed times the time. Now this one will be m, this speed, which allow me, I'm going, instead of using s, I'm going to use v. So I'll have v a t. However, now you are going to learn when you advance that from here, from this point, is where we shall bring in those integrals. So this one will come at a higher level where data half comes in. And it will come in more so when you go on and cover, there is a topic we are going to cover in motions, where we have that our displacement can be given by half at squared. So you'll find it when we advance data half, but it usually comes in as a result of integration. So at this level or at all level, you don't derive how kinetic energy. For you, the only thing you need to know is how the formula comes about. But data half comes from either what you call the relativistic energy formula from Taylor's expansion, or it comes from integrating of energy. But that one allows us to cover it at the right time when you reach a level. That's why you'll find it. Yeah. Okay. Hope it is very okay. The person who asked, I wanted to just give you how it comes, but I'm not going to go into integration because it is not at your level. So here, you just need to know the formula, and then the rest you'll find out there. So I want us to try out some numbers using, so I'm going to write the question and then we are going to try it out. Okay. Okay. So the first number is going to tell us, find the kinetic energy of a car of mass 1.5 tons. Roman 1 at rest, and Roman 2 moving at 10 meters per second. So I want you to tell me in the chat. Now, always, whenever you are dealing with physics, always first summarize your question. Now, when you look at our question, but people, let me just first ask the class. Don't we want to first try it on our own? Unmute and tell.
Yes.
Okay.
Yes.
Okay. Let us first try.
Yeah.
No, I want to, let me give you some 2-3 minutes. Everyone first try on your own. Yes, but the only trick I want you to take note of is what you call 1.5 tons. Who can raise up the hand and you first give us that hint? Because that is what is important. Yes, Sean, unmute. Sean?
The 1.5 tons we first have to change it to kilograms.
Good.
Which will be equivalent to 1,500 kilo.
Okay, very good. Thank you. Now, everyone, please take note that in 1 ton, you have 1,000 kilograms. And remember, mass must always be calculated in its standard units. So you ask yourself, when I have 1.5 tons, how many kilograms do I have? So you cross multiply. So that means you have x equaling to 1.5 times 1,000 which will give us the 1,500 kilograms. Now, this is your mass. Are we trying it first? Is anyone trying? Okay.
Yes.
Okay. Let's try.
Yes.
Okay, good. Let's try. So when you finish, you put for us your answer in the chat that Roman 1, I'm getting this. Roman 2, I'm getting this. Semakula, which screen are you seeing? Which screen are you seeing, members? No one is answering.
None of the activity.
Oh, the whiteboard, eh? Okay.
Yes.
Okay, good. I'm looking through the chat to see those who are getting. I'm seeing Austin is getting some answer. He's getting some answer. Okay. Let everyone first try. When you finish, you let us know, and then we can try it, and then you mark your solve. Yes, Techno, unmute. Techno? Oh. Okay. Techno. Okay. Everyone is trying. Is the number coming out? We may be here when it is coming, eh? Okay. I've started seeing some answers. Annabelle Petrina is saying, Roman 1, it is 0. Roman 2 is 7,500. Sean is saying it is 750,000. Okay, okay. So give a chance to the rest. So we are giving you 2 minutes only. We are giving you 2 minutes. Those who have not tried. Hope you are still seeing my board.
Yes.
The whiteboard, eh? Okay.
Yes.
Hi. So we are giving you more 2 minutes, everyone to complete.
I've finished.
Okay, finished, good. And the rest?
I have finished.
Okay.
I have finished.
I have finished.
Finished.
I have finished. I have also finished.
Okay, okay.
Done.
Yeah, all
They're
Okay,
done.
sir.
okay, good. Now let us go back to the answer. Who's answering question 1? Question 1, raise up your hand and you tell us which answer you have. Yes, Austin.
Sir, I have 0 joules.
Okay, you give us the reason.
The reason, because it is at rest and there is no speed there, and because there's a 0, the 0 affects all the other answers. And yes, the answer is 0 joules with the units.
Okay, good. Thank you. Thank you. That is good. Someone who has not given an answer today, raise up the hand to take us through Roman 2. I know Irina as if she has given us. Natasha has given us. Erin, have you contributed today?
Not yet, sir.
Okay, take us through Roman 2.
Okay. When we are using the formula of finding kinetic energy, it is a half mass times v squared. Now, since our mass is 1.5 tons, and we have converted them into kilograms, which is 1,500 kilograms, times the speed, which is 10 meters per second. Now, once we use that formula and we multiply it, we shall get an answer of 7,500 joules, since that is the unit in which energy is measured.
Wow, wow, wow. Thank you. Thank you. That is the answer. Unless someone, in case you have a question, you can kindly let us know. In case this is not the answer you're getting, you kindly let us know. Okay, let me ask. Yes, Blessing. Blessing.
Teacher, I beg pardon on that question.
Oh, no, okay, I was asking, do you have any question? Did you get the answer?
Yes, sir, I did. Both the answers.
Both the answers, good. That is good. Okay, Now, another way you could reason is that at rest, you have no speed, you have not covered anything, you have not moved.
Yes.
So your V is 0. Okay.
Patricia.
Okay. So allow me to share. We continue. So I'll come back in peace. There is another one here. So we are trying it. Let everyone first try, and we put our beautiful answers in the chat. So put your beautiful answer in the chat. First try it out. And once we pass it, then we shall be good. Shall be good. Okay, put your beautiful answer in the chat. Put your beautiful answer in the chat. I'm going to read Semakula 4,000. Stace Alaf 4,000. Cuts 4,000. Sean 80,000. Okay, I'm waiting for the other beautiful answers in the chat. Let me now allow even people to see your answers. Elena 4,000, 4,000. Annabelle 80,000. So either anyone, Annabelle or Sean Kalibuna, one of you. Natasha 4,000, 4,000, 4,000, 80,000, 80,000. Anyone who has 80,000, raise up the hand. Melissa 80,000. Those with 80,000, Derry. Oh, now we need to see. I'm seeing. Okay, now I'm going. Let me start with it. DRK. Unmute.
Yes, please, teacher.
Yes, take us through how you have obtained your answer.
So since we calculate kinetic energy using a half mass times velocity squared, I got a half times 400 times 20 squared.
Yeah.
Which is equal to a half times 400 times 400.
Yeah.
Then you get 400 then you get 400 out of 2 divided by 2 times 400. Then 400 divided by 2 gives you 200 times 400, which equals to 80,000.
Okay, good. Those who are getting something like 4,000. I don't know where your mistake was. Someone to tell us, anyone who had 4,000, to tell us where you made a mistake from. Okay, yes, Natasha. Natasha?
Our mistake for us who got 4,000, you see the formula says that the formula is the kinetic energy is equal to a half mv squared. So for us who got 4,000, we had left out the squared.
Oh, okay. Thank you. Elena, is it the same? Elena?
Yes, sir.
Is it the same reason?
Yes.
Okay, good. We try out one more. Oh, we are trying out one more to check out. We try out one more to check out our stamina. One more. So choose the one you want. Everyone, feel free to choose. No problem. Or the one you want. We are doing just one number. No, but why don't we do this in our free time? Yes, take a screenshot. This is your exercise. You will try out. Just take a screenshot. Take a screenshot. You are going to try it in free time. Yes, such that you can be able to look at something also. Okay, hope everyone has finished. Okay, now we are going to look at another form of energy we call the potential energy. Whenever you are at rest, now like many of you are seated down looking at your computer, the only thing that is moving is your hand, but your body, the biggest percentage of your body is down. We shall say that you are possessing potential energy. That's why with potential energy is that kind of energy that bodies that are at rest possess. Whenever you are not moving, you are static, you are in place, you have not started any movement, you will be possessing potential energy. So potential energy is that kind of energy that bodies which are at rest possess. So let us also make some kind of write-up. And in the chat, can everyone type, wait. I want to see, what is the formula for potential energy? Type it in the chat, those who know it. Let us see who knows the formula for potential energy. In case you know the formula for potential energy, type it in the chat and listen. Oh, Stacy Alf is saying G. Okay, I've not. Oh, okay. Martha is saying mgh. I have times mass. I have mr. Okay, okay. Thank you so much for trying, everyone. Okay, okay, okay. mgh, that is instant. Okay, good. mgh. I think we're getting there. I have mgh. That is Tracy and Blessing. Okay, okay. Okay. I'll say now the correct answers are coming. So the correct answers are MGH. I have MGH. Something is missing. Something. Yes. Okay. Thank you. Thank you. That is it.
Excuse me, Mr. Kaziwa, your mic is muted.
Okay. Hope people have finished. Hope people have finished. Okay. Okay. So we can continue. Sorry. Okay. Sorry. Allow me to first. Just give me a minute. I don't know what's really happening. Okay. Sorry. Okay. Sorry. Something is really happening here. Okay, okay. Sorry. Okay, let me just write. Let me just write because something is not just. Okay, so our potential energy is going to be, our potential energy is going to be given by, so the formula for finding the potential energy is given by mass times gravity times h, whereby m stands for the mass of the body, then we have g, which stands for acceleration due to gravity, and then the last one, this is acceleration due to gravity. And the last one is h, which stands for the height. So those are the three variables. So depending on which book you're reading, in some books, you'll find them using potential PE to represent potential energy or the work that is done in lifting something. That's what we call potential energy. So that is what we call the potential energy. So we are going to try out a number, and this is the number. We can write the activity that we are going to try out. So it says a 40-kilogram boy climbs a tree to a height of 5 meters to pick mangoes. Determine his potential energy. Now, at this level, we are going to assume G is equal to 10 meters per second squared. So can we first try it? Is everyone in position to try that number using the formula?
Yes.
Okay. Let's first try. Okay. Are we getting some answers, members? Are Are we getting some answers? Looking through the chat.
Yes.
Wow, good. Good.
100.
Anyone getting 2000 joules? 2000?
Yes.
Okay, good. 2000, that is good. Anyone who's not getting 2000?
Yep, 1000.
Are we all getting 2000?
Yes. Yes.
Okay, good. I'm putting another question. I'm putting another question.
Yes.
So the answer is 2000. In case that's not what you have, raise up your hand and we help. Okay, yes, Blessing. Unmute.
Teacher, so here when you told us to assume that acceleration due to gravity is 10 microseconds
Oh,
negative 2.
meters per second squared. We read it as meters per second squared. Yes, Blessing, you can repeat.
Meters per sec. Okay. Here when you told us assume acceleration due to gravity is 10 meters per second negative 2. So me, I assumed that the value is written as 10 meters per second out of 2. Is it correct?
Oh, okay, 10 meters out of second squared, like that?
No.
Hmm.
I wrote 10 meters per second out of 2.
Oh, no. So, like when you talk about acceleration, its units are meters per second squared. So it means meters out of second squared. These are units. Or when you find this, it means the same thing. So these ones are just units.
Okay, teacher, thank you. Yes.
Okay. Yes, Charles. Charles, ask. Muhozi, ask, and Irina, unmute. Just unmute and ask.
For me, the question I'm asking, since you've told us that the units for acceleration due to gravity is meters per second squared, but in some cases you find it as meters per second as if without having a square unit, maybe like -1. Is it also okay?
Yes, now these are the two major, this is how they can write them. Only these two formats. So when you find a -2 up, you are not going to find the dash. Hope that is okay.
Yes, sir.
Okay. Another one. Yes, Muhozi. Muhozi, ask. Okay. I'm failing to get Muhozi. Yes, Blessing. Okay.
Sorry, sir, it was a mistake.
Okay. Now, who can tell us which trick is on this number? Anyone who has noticed that trick? Who has noticed that trick on this number? There's something hidden you need to know. Anyone who has noticed something? Divine? Divine, unmute. Oh, Divine is not unmuting.
Okay, yes, it wasn't allowed. So I think it was the mass.
Yes, good. It is the mass that we are supposed to convert to kilograms. So before you do any calculations, make sure you have converted your mass from grams to kilograms. So first convert that. And this one, you do it as your side work. So for this number still, make sure we assume G is equal to 10 meters per second squared. Yes, Mohoz.
Chair,
Yes.
what is gravitational force?
What is gravitational force? Anyone with an idea? Who knows what gravitational force is? Annabelle? Annabelle? Okay. Annabelle, unmute.
Gravitational force is the force that pulls objects towards the center of the earth.
Yes, this is the force that pulls things towards the center of the earth. Good. Tracy and Blessing. Martha. Martha. Oh, okay. I'm failing to get Martha. So that force that pulls things. Oh, okay. So that force that pulls things towards each other, that force of attraction in which objects are pulled towards the center of the earth is what we call the gravitational force. It is a force that is in nature and it is always attracting things, or it is, in fact, we call it being conservative. It is the unattractive force which pulls the things towards the center of the earth. So for you, when you throw something up, it will be pulled back down. So that force that pulls it back down is what we call the gravitational force, or the force of gravity. So it always, for it, pulls things towards the center of the earth. And that force cannot be broken. I think the only person who has broken it is only Jesus. Otherwise, no one can go up and you don't come back. You have to, once you go, you have to come back down because it will always pull you. So it was only Jesus that went against the force, but no one else can do it. Maybe, you never know, we may have another Jesus that can do it, but you cannot go against it. Okay. Okay, Sasha. Okay. So the potential energy, now I'm going to start with this number. So we know that potential energy, in some books, you may find them using U. Those are correct. We have mass times gravity times h. Now, when they tell that something is on the ground, take an example. Many of you know a bookshelf. When you are in your room, in your house, we know that a bookshelf will always be placed a bit up, or it is up. So when the book is on the ground here, its distance is 0. It has not covered any distance. But when you move it to the bookshelf up, it has covered a distance. So when it comes to Roman 1, since the book is on the ground, it means that height is equal to 0. However, our mass was given in grams and we want to change to kilograms. Now, always remember that King Howard died, the men, dogs cried much. Hopefully you use, there's another one, they use King Henry's daughter Mary poured milk. So now for you start, what do you want? From grams to kilograms. So here, this is where you place your grams and these are the kilograms. So you say 1, 0, 0. Meaning that in 1 kilogram, you have about 1,000 grams. So whenever you are moving from a smaller unit towards the bigger unit, you always divide. A gram is small and a kilogram is big. So when you are converting to kilograms, you always divide. So I'm going to just get 500 divided by 1,000, which is going to yield, that is 0.5 kilograms. So for Roman 1, I'll come and I say potential energy is equal to mgh, but mass is 0.5. This is 10 and the distance is 0. So that means your potential energy is 0 at that point. When I go to the second Roman, When I go to the second Roman, I can notice that potential energy still will equal to mgh. Our mass remains 0.5, acceleration is 10. Then the height, that is the distance through which this book has been moved high. So it has moved high 1.5 meters. So you place your calculators. What do we get? What do you have? Anyone who has got the answer? Yes, Zayomi. Any answers, Zomi? Unmute. Martha, Elena, any one of you can unmute and tell us what you're getting. Unmute. Unmute. What do you have?
7.5 joules.
Do we have 7.5, everyone?
Yes. Yes, sir.
Okay.
Excuse me, sir.
Yes, please.
How did you get 1.5 on height?
It is here. Are you seeing question B, Roman 2?
Yes.
It is here. Have you seen?
Yes.
Okay.
Hey.
Okay. Okay. Yes, Natasha?
I also got 7.5.
Okay, perfect. Okay, now we are going to do an activity. So allow me to stop sharing my screen. I'm going to stop this recording.